Alright, so just a quick explanation of what's going on in the example at the bottom of page 3. So we've got an equation here, and this video is just going to serve to show how this is actually a redox equation and a redox reaction, even though it's not really that evident right now. Okay, so this isn't so much a method to follow as something just to be aware of and appreciate that oxidation and reduction is occurring. All right, so if I was to split up this ionic compound, what would I get here? Well, I would get 2 silver ions, and I'd get 2 nitrate ions, and I've got my copper metal there. And if I split up this ionic compound, I'd have my copper 2+, and I'd have my 2 nitrate ions, and then I'd have my silver metal. Okay, so if we're speaking about reactions going on here, we kind of want to just concentrate on the species where the reaction is occurring. So any species where they're not being involved in the process, I'd kind of want to just kick out for the time being. So that's where this and this, we can recognize that these are spectator ions. So we can just discard them for a moment, and that's exactly what it says in your booklet. So nitrate is a spectator ion, it is a reactant and a product. All right, so removing that, what are we left with? We're left with 2 silver ions, we've got our copper, we've got our copper 2+, and we've got our 2 silver. Now, I'm not putting in the states because the question in your booklet hasn't. Okay, so what we need to think about now is identifying what is being reduced, what is being oxidized, all right? And the way we do that is we write these really basic equations called skeletal equations. And so if I have a look at silver here, it's being changed, isn't it? Okay, it's going from being positively charged to having an overall charge of nothing. So I'm going to write that down. So well, I can just write Ag and just keep it balanced. Ag. Okay, and so that's my first skeletal equation. And then my other skeletal equation is copper changing to copper 2+. So clearly a change is going on here, okay, and a change in charge. So this suggests to me that electrons are being transferred. So we need to balance these equations. This has an overall charge of +1, and I want to balance that out to 0. Okay, we've got a 0 charge here. We want both sides to have the same charge, so I'm going to add an electron. I can only add electrons. Okay, so this is an overall charge of 0 on this side, and this is overall charge of 2+, so I have to actually add 2 electrons here. Okay, so these equations here are what are called half equations, and this is what we'll be discussing in the next few lessons, how to form these properly and follow a method of how to write them out. Okay, but this video is just showing you how redox occurs in this equation where it looks like it's a bit hard to tell. All right, so just having a look at this half equation, do we think it's oxidation or do we think it's reduction? Now, electrons are being gained, so this is an example of a reduction reaction. And here, well, electrons are being lost, so this is an example of oxidation. Okay, so this copper is being oxidized. Okay, this silver is being reduced. And so we know that if something's being oxidized, it's actually the reducing agent. And if something's being reduced, it's the oxidizing agent.